So today I'm talking about the electric starter on the Polini. This is the starter itself, and so I'll start at the starting where the starter is. The starter is driven by this electrical connection. On this particular motor, the electrical connection is fastened by a screw with a lock nut. That terminal that it's fastened to, though, will also fit a spade lug connector. I would not put a lug connector on there, though, because of the vibration of the engine and the weakness. Those tend to be weaker. This is obviously going to be a much better connection. I have a really good connector put on there. From that wire, the electricity comes from the relay or solenoid, depending on how you want to call it. In old cars, these were called solenoids. This is a relay, and it has a capacity of 200 amps. I have measured the current with the starter. It's around 80 amps while it's starting, and that seems like it's going to be enough. But the problem with relays is that the contacts can get carbonized over time. So after a while, if you start it often enough, every time you press the button and the relay activates, there's a high amount of current that goes through the starter, and that sparks, and those sparks can cause carbon to form on the contacts of the relay, and that will cause the relay to eventually not pass any current. So if your starter is not starting and you're hearing the relay clicking, then best point is probably to just check the voltage here and make sure that you're actually getting a 12 volt current or a 12 volt to signal arriving here at this screw. If not, then you got to go back and check at the relay here. Now, on the other side here, there's two big fat connectors and there's two thin connectors. The other bigger connector, one bigger connector, of course, here goes to the starter. The other bigger connector goes up to the battery. And these are screw terminals. Let's see if I can get that off of there so I can see. Well, these are screw terminals held on with nuts and washers and star washers and stuff. There it is right there. There we go. And so they're capable of carrying a lot of current. Now, the other two smaller connectors on here, let's get the stuff out the way so you can see it. The white one and the other red wire going up into there. The white connector has a yellow-red wire going into it. Let me zoom in a little bit on that to make that a bit clearer. There we go. So the yellow-red wire going into the one side is coming from the battery power directly. That's actually directly connected. It's hard to see, but it's directly connected to the battery through this connector here that comes into it's just a short wire. It comes out of the, I think we should be able to see it right there. You can see it coming out of the cap. So that's just plain straight up battery voltage. It should always be 12 volts as long as the battery is connected and on and everything is good. The other side, this thicker red wire on mine, is coming from the starter button on the handle, and it should supply ground. So if you're not getting the relay click, you want to check the current, or you want to check the resistance from this wire. Pull this wire off and connect resistance, check resistance from there to ground. If there's no resistance going to ground, then there's something wrong with the button circuit and you have to troubleshoot that out. So the way this whole thing works is the 12 volts, a small amount of 12 volt current triggers the relay. The relay triggers a bigger switch that allows the current to go through to the starter. That's just the whole general system. Now, a couple things to watch out for. You got to make sure, of course, that this big thick cable is going to the battery. I have a circuit breaker built into mine, which comes through this red wire and looks like this. So I can turn it on or turn it off. And if too much current flows through there, then it doesn't make the battery catch on fire because the circuit breaker will trip. That's, I think, a 80 amp circuit breaker. So it's, correction on the starter, it was a 60 amp, I think, or 50 amp starter. So at any rate, maximum of 80 amps is going to go to that starter before the circuit breaker trips. And the other thing, so you got to make sure that this wire is connected. The other thing you got to make sure of is that the black wire from the battery is going to a good solid ground. Mine comes down to here, and right now I have this loose because I'm working on it, but this thick wire is the ground wire directly from the battery. I connected the battery ground directly to, as close as I could, the starter, so that the starter gets as much, has as much power to it, or let's say the least amount of resistance going through all of the connections. More connections increases the resistance, and that drops the voltage and increases the heat of the current going to the starter. So make all the wires as short as possible, but make fewer connections, as few connections as possible. That's the Polini starter system, Polini 190 starter system.